Today we're going to be looking at division properties of exponents. So dividing powers of the same base, for every non-zero number a in integer m, a to the mth power divided by a to the nth power equals a to the mth minus n. So we subtract the exponents. So let's complete each equation. So here we have 5 to the 7th divided by 5 to the 32nd power. So we know that we have like bases, which are 5. So that means we can subtract our exponents. We have 7 minus 32. So we have an exponent of negative 25. Here we have like bases of 2. So 9 minus 3. And 9 minus 3 is 6. So this is 2 to the 6th power. Here we have like bases of 3. So 3 minus 10 is a negative 7. Here we have 4 bases that are all alike. So since we are multiplying, we can do 5 to the 4th power times by 5 to the 6th. So we add those exponents. So that means we have 5 to the 10th divided by, 5 to the 3rd times by 5 squared. We add our exponents of 3 and 2, so it's 5 to the 5th. So now we can take our like bases and subtract our exponents, which is 10 minus 5. So this is 5 to the 5th power. So here we have 3 divided by 9, which we can reduce down to 1/3. 3 goes into 3 once, 3 goes into 9 3 times. And then we have s to the negative 4th divided by s to the negative 7th, so like bases. So we have negative 4 minus a negative 7, which equals a positive 3. So we have s to the positive 3rd power. So if we just rewrite this as s to the 3rd divided by 3. Here we have a like base of x to the 7th divided by x to the 7th. 7 minus 7 equals 0. So we have x to the 0 power. Then we have y to the 5th divided by y to the 1st. So we have 5 minus 1, which equals 4. So y to the 4th power. So if we simplify that, it's y to the 4th. Here we have 6 squared divided by 3 to the 5th power, and those are not like bases, so we cannot do 2 minus 5. So let's see, we have 6 to the 2nd power, which is 36, 6 times 6. 3 to the 5th is 243. Here we have like bases for our m's. We have m squared divided by m to the 7th, so we're dividing, so we take 2, subtract 7, which is a negative 5. So we have m to the negative 5th. T's are like bases, so t to the 9th divided by t to the negative 2nd. So we have 9 minus a negative 2, which equals a positive 11. So simplify this, so we have no negative exponents. We have 36, t to the 11th power, divided by 243, m to the positive 5th power. Here we're looking at scientific notation and dividing. So first we have 2 7/10 divided by 9 times by 10. Since we are dividing like bases, we have negative 7 minus a negative 2, which equals a negative 5. Well, 2 7/10 divided by 9 is 3/10. So we have 3/10 times by 10 to the negative 5th. But this is not in scientific notation, so we need to move that decimal so it's behind our 3. So it's 3 times 10, and since we moved it one more back, it's negative 6. So looking at this next one, we have 3 6/10 divided by 6 times by, we have like bases of 10. So we're able to do 12 minus 3, which equals 9. So it's 10 to the 9th power. So 3 6/10 divided by 6 is 6/10 times by 10 to the 9th power. We are moving our decimal, so it's behind the 6, so it's 6 times 10 to the 8th power. Now let's look at raising a quotient to a power. For every non-zero number a and b and the integer n, if we have the quantity of a divided by b raised to the nth power, it equals a to the nth divided by b to the nth. So here, 4 times a divided by 2 times b, so that means we have 4 to the third times by a to the third divided by 2 to the third times b to the third. Well, we have no like bases, but 4 to the third power equals 64, a to the third, divided by 2 to the third is 8, times by b to the third power. So the last thing we can simplify, well, 64 divided by 8 is 8. So we have 8 times a to the third divided by b to the third power. Here we have 6 squared divided by n to the 6th. We're still doing a power to a power, so we have the 6th power raised to another power, so we multiply those two. 6 squared is 36. 6 times 2 is 12. So we have 36 divided by n to the 12th power. Here we end up with 3 to the third power times p to the third power divided by 2 to the third power. Well, 3 to the third power equals 27 times p to the third divided by 2 to the third, which equals 8. Here we have negative 2/3 to the negative second power. So that means we have negative 2 to the negative 2 power divided by 3 to the negative 2 power. So if we need to rewrite this, so we have positive exponents, we have 3 to the positive 2 in the numerator, 2 to the positive 2 power in the denominator. 3 squared is 9, and 2 squared is 4. So if we take our power of 2, so we have 3 squared times by x power to a power, so 4 times 2 divided by 15 squared. 3 squared is 9. And we're going to do 4 times 2 to get our next power, which is 8. 15 squared is 225. That is our final answer. Looking at our last one, we have c to the 5th power, but it's raised to another power of 3, so we can multiply the 5 and the 3. C to the 9th power raised to the 3rd power, so we multiply the 9 and the 3. So 5 times 3, we have c to the 15th. 9 times 3 is 27. So our last one, we are dividing like basis, so that means we take our exponents, which is 15, and we subtract 27, and 15 minus 27 equals a negative 12. So we have c to the negative 12th power, but we want to simplify this so we have a positive exponent. So it's 1 divided by c to the 12th.